Tēnā koutou katoa, ko Sam Brown toko ingoa. Welcome to the third talk in our Mammal Pest series for Biosecurity Bonanza 2022. It's my privilege today to introduce Bruce Warburton, Science Team Leader of the Wildlife Ecology and Management Team at Manaaki Whenua. Bruce has a wide area of interests and expertise in the pest control area, including pest management strategies, animal welfare and ethics, novel technology, disease management, and trap design. Thermal cameras and UAVs are getting increasing exposure and are being seen as technologies that can provide more cost-effective methods for monitoring invasive species. Manaaki Whenua has been carrying out some pilot trials of both technologies, and this talk is to share our initial results and the pros and cons of using these tools. This work developed from using UAVs with thermal cameras to monitor an ECAN wallaby control operation. A Q&A session will follow this talk. I encourage you to submit questions during the presentation. We will try and get through them all, but if not, Bruce will respond by email to any questions we don't get to today. I'll now hand over to Bruce to share his presentation on thermal cameras on helicopters or drones, some pros and cons of new technology.
Cool, thanks Sam. Can you hear me and see my screen?
Yes, you're fine, Bruce, go ahead.
Yep, okay, good. Well, kia ora koutou. Thank you for joining this webinar series. The topic area, as Sam said, really came out of some work we were doing for Environment Canterbury last year. They asked us if we could test the use of UAVs and thermal cameras for assessing the percentage kill that they might be achieving with their 1080 operations against Bennett's wallabies. So in this talk, I want to cover three things really. I'll look at the control operation that we monitored in detail and show you some results of the percent kill that we achieved. And then I just want to go through two parts. One, just looking at thermal cameras by themselves and the technical issues around them and what we've learned from using those. And then some pros and cons of using UAVs or drones and helicopters. And I don't profess to be an expert on this technology, so this is more of a biologist perspective of these technologies. So firstly, just looking at the work we did for Environment Canterbury, assessing the percent kill. So the UAV we used was a DJI Matrice. It's a quadricopter, so you can see a photo of it there. And this was supplied by GCH Aviation. So we didn't actually have the technology and do the work. We subcontracted a company that's an expert in this area. The thermal camera we used was again a DJI Zenmuse camera, which is integrated into the UAV. The resolution of that camera was 640 by 512, as you can see there. And we surveyed 8 1-kilometre transects in both of a treatment block and a non-treatment block. We flew these transects twice, pre and post control, and we flew them starting about 30 minutes after dark, and went through to about six hours after dark. So it was sort of pretty well midwinter. So we started 6:30ish and we flew through to about midnight. The UAV was flown nominally about 60 meters above the ground, and the camera was tilted down about 40 degrees from the horizontal. So those specifications gave us a swath width of the camera of about 60 meters. So that's the swath width of the transect that we flew. So this is just an image of our study area. So it was on the eastern side of the Mackenzie Basin. The H there is denoting the Hakataramea Pass. And the red transects there were our non-treatment lines, and the yellow ones were within the poison area. So straight to some results in the poison block, and you can see here really what it shows, it's particularly in the pre-control on the lines here, how variable they can be from night to night. And that's generally reflecting the sensitivity of wallabies to wind. If you have a calm night, they can be out on exposed spurs and ridges. If there's a slight cool breeze, chill factor, they then shift down into the scrub cover or into the gullies. So the counts can be quite variable from night to night, and they vary between the transects that we flew. And then post control, you can see that they did actually achieve a very high percent kill. We only detected one wallaby post control. The non-treatment area, again, the same, quite variable between nights, particularly post control here, went from a 3 to a 10. But overall, quite a few wallabies in the non-treatment block post-control. And again, that's just environmental factors that are influencing the numbers that we see. So when we put those data into statistics, analysed them, the non-treatment block had an increase, as you would have seen in that table, but that was non-significant. There was a significant decrease in the treatment block and the poison block, as you would expect. And the estimate came out that the ECAN achieved a 98.4% kill of wallabies. So they were really pleased with that. I think that was probably an overestimate, but that's what the numbers told us. So that was really good. They were really pleased with that result. So now I just want to go through what we've sort of learned in using the thermal cameras, and I just want to share that with you, because if anyone out there is thinking of using thermal cameras and UAVs, what we've learned might be useful for you to think about whether you use this technology or not. So one of the things you need to be aware of is the camera resolution and the number of pixels on an animal. And the military sort of use these criteria, Johnson's criteria, detection, recognition, and identification. And it's really about the number of pixels that you're getting onto an object to allow you to identify it. So if you're only getting 2 to 4 pixels on an object, you can identify that as something hot. Something is there, but you don't really know what it is. So the images here on the left are just showing these sort of white blobs. You know there's something warm there, but it could be a sheep, it could be a wallaby, maybe it's a cow, maybe it's a hare, you just don't know. So if you can get more pixels onto that object, you can start recognizing that as a species, and if you get even more on, you might be able to differentiate. It's not just a deer, it's actually a stag. So you can see here on the right, this object here has a lot more pixels on it, and you can clearly see that it's a wallaby. So you need to be aware of the resolution of your camera and how many pixels you want to get onto that object to identify what it is. And the resolution's all sort of tied up with pixel pitch, which is the distance between each of the pixels. So the higher resolution, usually the smaller the pixel pitch, and the sensitivity. So that's the thermal sensitivity of the sensor that you're working with, and frame rate. So the resolution and the pixel pitch really tie in to making decisions about how far away you can be from your object, and therefore what the swath width is. So if you look at the diagram on the right-hand side there, the higher you are, the wider the swath width is. So you're surveying more area with every transect you're doing, but you're getting less pixels on the object. So you have to optimize that, or just balance those competing factors with each other. If you need to get a high number of pixels on an animal, you have to fly lower, your swath width is narrower, therefore you have to do a lot more transects to get the same amount of coverage. So it's just a trade-off that you're playing with all the time. The common resolutions that are available in commercial cameras can be as low as 80 by 60 pixels, which are really cheap thermal cameras. up to the highest ones that I'm aware of that are available commercially, and they're 1920 by 1200. So that's, you know, very high definition thermal cameras. And typically they come with a higher frame rate too. So the two frame rates that are generally available are 30 frames per second and 60 frames per second. So the higher the frame rate, the faster you can fly before you get blurring. So again, frame rate's critical in terms of thinking about what sort of speed you might fly at, so you don't get that blurring. So this is just a couple of examples of photos from a very high quality camera. So this Salix Merlin thermal camera is a military grade camera from the UK. The BBC actually used these cameras to film a whole documentary series on wildlife at night, just because it was such a high quality camera and gave exceptional imaging. So the image on the left there, even at 100 meters, which is not too far away, I mean, clearly you can see a rabbit there, there's a hedgehog there, and a bird there. So really clear imaging and sharp. And then just zoomed in, the same camera zoomed in at 250 meters, and you can see a female possum there and a back rider on the tree here. So again, if you can afford to pay for high quality cameras, you get high quality images. So basically in the thermal camera world, you get what you pay for. These cameras are hundreds of thousands of dollars and are way above what we can afford. But we had the opportunity to use this or see it being used on the Port Hills a few years ago. So that gives you an idea of the quality of the pictures that you can get out of thermal cameras. Some cameras are radiometric, not all of them are, but some of them are. So that just means they record the actual temperature of the pixel. So like a normal colored camera, you know, is recording RGB, you know, whether it's red, green, or blue, or whatever. The thermal cameras can also record, the radiometric ones can also record the actual temperature of the pixel, and then that can be queried at a later date, as I've shown here, and you can look for animals by querying the data. And the top graph there shows a possum, and the bottom one is there's 4 deer in that image, and that's just showing up quantitatively in the data. So again, that's a useful add-on if the camera has that capability. Now, one thing I just wanted to talk about briefly is using thermal cameras for monitoring or hunting, and using them for detection and surveillance. And we've done some work in the past, Dave Latham and I, a colleague here, Dave, and I did some work for MPI 2 or 3 years ago, and we got a wee bit of pushback because the detection probabilities we found for thermal cameras were reasonably low. And some people that use thermal cameras say, well, you know, we see a lot more animals than what that would suggest. So I just wanted to work through this with you just to clarify the difference. And these are just made up figures, so don't take these as gospel. So you might go to an area and you might see 30 just visually. So that could be flying in a helicopter, looking out the door, or walking through an area, or walking through an area with a dog or whatever. So you see 30. But if you had a thermal camera with you, a thermal scope, you might have seen 60. And you can say, okay, the thermal was twice as good as the visual. And they are, if any of you have used thermal scopes for hunting particularly, you do see a lot more animals. I mean, they are very effective at finding animals that you just wouldn't see visually. So that tells you, yes, they are a lot better than just visual observation. But for detection, you really need to know how many animals are present to actually try and find. And in this example, I've just said, well, let's say there's 100 there. So for the thermal monitoring, even though you saw twice as many as you did visually, the detection probability of that thermal camera was still only 0.6. So there was 40% of the animals, you still weren't detecting. And it's actually very, very difficult to determine this detection probability, because generally we do not know how many animals are present. You don't know what you don't see. And that's a big challenge in this field of work, is measuring these detection probabilities. And there's some ongoing work in this space to try and get better parameter values on this detection probability. So I hope that makes sense. So this is just, I've got a couple of video footage of some video here just to share with you, just to show some of the challenges. And there's always false positives, false negatives, and the issue of scale. So just talking briefly of scale. So you can be flying up a ridge, surveying an area, and your swath width might be 60 meters, but you just fly over a bit of a knoll, a bit of a knob, and your field of view goes from 60 meters, and you might be looking at a distance of 60 meters, 80 meters, and that distance goes to 100 meters, and your scale perception just changes, and there might be a hare there, and you think, is that a wallaby at a distance, or is it a hare closer up? So it's when you're viewing these videos, sometimes it's often very difficult to deal with that scale. It can be confusing, and because of that, you've got the risk of falsely saying it as in this case, a wallaby, or saying, oh no, it's not a wallaby, it's actually a hare. So there's this error rate creeps into your analysis. So when we did the analyses of the videos, we classified the identification as definites. As you can see on the left there, definites, probables, and possibles, and we just used the definites and the probables in the data that I showed earlier on. So if we look at this video up here, there's right under my laser pointer there, there's actually a wallaby. So if I run the video and you just watch it, so when it's moving, it's really clear, and then it stops and it just sort of disappears into the background, these other white things, and you just never know how many of those animals you're missing that aren't moving. When they move, it's clearly a wallaby or a hare or whatever you're interested in. When they're not moving, you just can end up with a lot of false negatives. You're just not identifying animals. So that's always an ongoing challenge. So we're a bit closer here. We're probably only about 30 meters from these animals, up above them. The white blobs there are Manaaki mushes. So all things in the environment have different shades of temperature. So Manaaki actually can show up as quite warm in the evening, so it's just absorbed heat during the day. Water, even small puddles and that show up. Scats from cow poo, you see them, they just glow in the dark, and you can pick them up hundreds of meters away. You see these things glowing in the dark, and you have to get close to try and identify what they are. And it's always disappointing when it just turns out it's just a big pile of poo. But anyway, here's some wallabies. So these are popping around, and clearly when you can see them, and there's no issue. But this one just moves under a Manaaki bush, and it stops, and it just disappears. So there's not much vegetation between that wallaby and the open air behind it, but that's enough to hide it. So again, when you're doing these surveys, you have no idea how many animals you're missing. And that's again the challenge with trying to determine what the detection probabilities are. And you can see if you're flying over more intact canopy, forest type habitat, there'll be lots of animals that you just can't detect. So although thermal helps you see a lot more animals, it doesn't see everything. So again, it's not a silver bullet, and you just have to be aware of its constraints and what the limitations are. So what other people are doing, and we haven't actually used this. So these two images came from Interpine, New Zealand. So Interpine is a company that does UAV work and thermal work. They're based in the North and South Island. So they have cameras. So DJI drones have another camera option where it integrates a thermal camera with a night vision camera. So a night vision camera magnifies the background light, so the dim light, it magnifies that. So it's not thermal, so it has a thermal camera and a night vision camera running in parallel. So what this can help do is, and the problem with thermal cameras, they're usually a fixed focal length, so you can't zoom in. If you really want to go and look at something, you've got to fly up to it and have a look at it. You can't zoom in and have a look. But night vision cameras, you do have a zoom lens. So in this example, there's two black spots here. So this camera's been set to black hot. So my previous images were set to white hot. So there's usually a color palette that you can select in thermal cameras. So yeah, we use white hot. This one is black hot. So there's two black images there. And then they've used the night vision camera. They've stopped and then used the night vision camera to zoom in on that object. And there's also with those cameras a spotlight, but it's an infrared black light. And the night vision camera is very sensitive to that. So they can zoom into that object, turn the black light spotlight on, and then have a look, and clearly that's a wallaby. So really good for identifying species at a greater distance. And this would be good for detection work when you're operating at very low densities, but it wouldn't be suitable for monitoring because every time you stop, you're changing your sample frame for monitoring. So it's not suitable for that. So lastly, I just want to get on to the pros and cons of UAVs and helicopters. So a lot of people think, oh, I can go and buy a drone at Noel Leemings or wherever and go and fly, and you can privately within limits. There's constraints on what you can do even as a private UAV user. But commercial UAV operators have to operate under a CAA Part 101, and depending on what they're doing, a Part 102. So if they're flying at night, they need to operate under a Part 102, and that basically just covers the details of how they're going to mitigate the additional risks that they're flying under that are not covered by the 101. So Part 101 doesn't allow you to fly at night. So if you're going to fly at night, you have to do a Part 102 and say how you're going to mitigate the risks of flying at night and get approval for doing that. And the company we work with, one of their mitigation methods was to have two operators. So you have to have two operators running the drone at all times. And again, that increases costs. So that has a significant cost implication of using drones for night work. So just looking at the pros and cons. So the pros are the good things about UAVs and helicopters. So for the UAV, the flights are totally autonomous. So they're pre-programmed. You go to your site, you download the mission or the flight to the drone. The drone takes off, flies to the start of the transect, turns, orientates itself, and then just flies along that transect and rises up the slope if it's going up a ridge, and then goes to the end of the line, turns around and flies back and lands. So it's totally autonomous. So there's no pilot involved. So flying at night especially, it's very safe. And that's a really big plus for using a UAV. If you're into climate change issues, there's low carbon because they're all electric. And the cameras in the UAV are usually fully integrated. So yeah, they're talking to each other. So again, very easy to use. The pros of using helicopters, They're not restricted by line of sight or altitude rules, and I'll talk about them as a con for the UAVs in a minute. They could be cheaper than a UAV, which is surprising to people, but it's model dependent, you know, which sort of helicopter you're using. You can change locations easily, so with UAVs, because they're autonomous and pre-programmed, you might get to the site and you think, oh no, we can't fly there, we need to just shift it, you know, onto this spur rather than that spur. You can't really reprogram it in a short time frame on the site, where with a helicopter you can make that decision quite quickly. They're faster, so you can capitalize on weather windows. You can do a lot more transects within a shorter time frame, and longer duration, so you can do more lines. Now the cons, UAV. So the visual line of sight, currently the regulations require that UAVs can only be flown within visual line of sight. There's several agencies, drone operators working with CAA, trying to get beyond visual line of sight approval. But as far as I know, no one has got that yet. I might be incorrect there, but as far as I know. What that means is that you have to try and get as close to the start line of every transect as you know, as close as you can, and the transect has to be sighted where you can see the UAV right through the length of that transect. So it limits where you can fly, basically, and it also takes time. It means you have to drive to the start of every transect. So there's a real cost involved in that. DJI UAVs, that second bullet point there, DJI UAVs have a max altitude gain of 500 meters. So even though we were flying 60 meters above the ground, because we were flying up the ridges, we couldn't go any more than 500 meters in real altitude gain, even though we were never above, you know, more than 60 meters above the ground. So again, there's just another constraint that you need to be aware of. And I think there are ways around that, but some of them have that constraint. As I said, with a positive for the helicopter, for the a con for the UAV is each mission has to be pre-programmed, so there's less flexibility in the field, and they can be expensive. You know, again, you might have to have 2 operators. You've got to be traveling between each of the surveys, so you can't do that each of the transects, so you can't do that many transects in an evening, so you've got to be there more days. So it's not necessarily an inexpensive option. The cons of using helicopters, they're not easy or cheap for flying at night. They're not easy to get certification for flying at night. It is possible. ECAN is just working with a helicopter provider at the moment to do some night flying, but it's certainly not easy, and it's not cheap. So there are certification challenges there. Again, climate change issues, they're high carbon emissions, helicopters, and the cameras in the helicopters are you know, not integrated. They can talk to each other, but there's not that full integration between the helicopter and the camera. So I think that's all. I just wanted to, my conclusions. So thermal cameras increase detections, and clearly you see more animals with a thermal than you would just visually. So I think they do have a real advantage and a really good toolbox a tool for the toolbox in pest management. You just have to understand what their constraints are and their limitations. When using them, there's an unknown number of false negatives, just missing animals. You just don't know, you know, what you're not seeing. And that's tied into the resolution. The higher the resolution, the better that will become. When using thermal for monitoring and hunting, the detection probability is unknown. So as I said, you know, you don't know what you're not seeing. So given there's one animal in an area, what's the probability that it is detected? And that's the probability of detection. and we don't really know. So UAVs, I think, are a useful platform for small areas because the current regulations restrict their utility, their visual line of sight rules. UAVs probably the cheapest option for night work, but again, for smaller areas, not for large scale areas. But UAVs not necessarily the cheapest option. So you really need to look at what is the best platform. You need to think about the sensor first. What's the appropriate sensor you want to use? And then what is the most sensible platform to put that sensor on? Is it a UAV? Is it a helicopter, or is it just a person? So just to thank Brent Glentworth, particularly Environment Canterbury, for getting us involved in this work, Colin Atkinson from from GCH Aviation, and Halden and Grampian Stations. So that's it all. Thank you very much. Sam.
Hi, Bruce. Thanks for that. We've got quite a few questions to get through, so thank you to the audience for starting to put those through. Was the drone recording video that you viewed later, or were the detections live transmitted to the operator?
Both. So the video is live fed to the operator. So, you know, I can stand next to the operator and watch the screen. It's an iPad, and you can say, oh, there's an animal, there's another one. So you're getting, a live stream, which is really good, but it's store on board and store on the console too, on the controller, and that's post-processed. You do that back in the office. Yeah.
And how long did the drone survey take per line? And so how many flights were there for pre and post monitoring?
So we were flying at 8 meters per second, which I think is about 20 kilometers an hour. So a kilometer long, it was only taking 5 minutes or so. So it wasn't taking a long time. The biggest time is setting it up at the start, pulling it apart, driving to the next transect, and these are in remote areas. So you're driving on remote four-wheel drive tracks at night, and you could only survey areas where you could drive your four-wheel drive to get to the start of the line, so you could be assured that you've got visual line of sight. So the actual flying didn't take that much long. That long, yeah. The time was the shifting around and moving between transects. Yep.
So would the drone mounted on thermal imagery cameras be of any use in forest or bush environments? Or are they only suitable for open high country areas?
I think the more open the habitat, the better the thermal is. But there are thermal camera operators that use their cameras for detecting deer in forest. So if there's canopy gaps, the heat will get out and you'll detect animals. I mean, and you'll detect a lot more animals than you would see just visually. So again, it's good, but the more closed that canopy, the fewer animals you see. And again, you don't know what you're not seeing. So yes, it is useful. You've just got to be aware of those constraints.
So what about using computer processing of the images?
Yeah, I mean, that's underway. You'll probably be aware that image AI, using AI for image recognition, is being developed for trail cameras. And I think Cacophony's working with someone to do some AI on their thermal camera imaging. So yes, that can be done. And if this sort of video capture was to become more routine, then yes, you'd want to develop some AI image processing, so you didn't have to sit and stare at the screen. But again, depending on the resolution, the challenges for AI to try and identify the correct species is challenge. It's hard for people. Yeah. Yep.
And could LiDAR be used instead of infrared?
I'll pass on that one. I don't know. I don't think so. I've asked our remote sensing people about whether we'd use LiDAR for detecting deer and forest, because it does detect that sort of 3D imagery, and they just said no. So so my answer would be no, but something that might be worth exploring.
Have you noticed any interference effects on pest behaviour caused by the drone presence, such as lights or propeller noise?
No, typically, so that video I showed, quite close up with those wallabies sort of moving around, we had flown into about 20, 30 meters of them, and you've got to get quite close before you actually start disturbing them with a drone, as opposed to a helicopter. When you're flying over just doing the surveys at 60 meters, you don't seem to have any disturbance factor. And if there was, it would just be minor. Yep.
And do you think thermal cameras could be used during the day to detect possums or wallabies that are camped up?
Yeah, that's a good question. So typically we do it at night because there's no solar flare. So if you've got a cloudy day, you can use thermal during the day. Ideally, you want the background to be as cold as possible, so only the warm things in the environment stand out. So the actual best time of doing thermal works first thing in the morning, because the background's cooled down overnight. But if it's a cloudy morning and there's been the sun hasn't got onto an area, you can do your surveys through the day. But as soon as you get some solar flare onto an area, it just sort of, it just flares out and it's no good. I'm aware that Grant Halveston, that he died a couple of years ago, but he was a sort of a lead person in using thermal cameras in New Zealand and Australia. He often saw possums in the tops of panga trees during the day. They were nesting just in the top of panga trees. So yes, you can detect them. Yep.
Why do you think ECAN result percentage kill was overly optimistic?
I think it's probably because there were animals we were missing, but proportionally that probably should stay the same pre and post. So maybe it wasn't over optimistic, but I think it's just I got an impression that there would be more animals there post control than we saw, but proportionally, maybe that should stay the same. So the percent kill should stay the same. So maybe I'm being a bit negative there. I mean, it would have been a good kill. They would have, it might have been a 95% kill. It certainly wasn't a low kill. Yeah.
Do you know if anyone is using UAVs with thermal imaging for assessing rabbit relative abundance?
No, I'm not, but we've certainly been thinking about doing that. But again, when we were doing this survey, the wallaby survey, it was surprising the number of rabbits. And I mentioned the scale issue. Often you'd see a rabbit because they sit up and they just look like a wallaby. They don't have the tail, but at a distance, you see the shape of them sitting up. And it's not until they move that you think, oh yeah, that's a rabbit, that's not a wallaby. And they're totally different in size. But when you get confused with the scale, things have shifted a wee bit. Often it's actually hard to tell the difference. So you can see rabbits, and there's no reason why a lot of survey transects that used to be done with spotlights could be done with thermal. But again, is it better to do it with a drone or just do it first thing in the morning with a helicopter? Because you could cover more ground with a helicopter. You're not limited by that visual line of sight. Yep.
So how many times did you sample each area, and could you get statistics for probability of detection if you did several runs of each transect?
Well, we only did the transects twice, so twice pre and twice post. You'd get a better picture of detectability, but I don't think you'd get that detection probability because you just don't know what you're missing. Yeah. I mean, it would give you a better picture of the detection probability of those that are detectable. Yeah.
And were the treatment and non-treatment areas flown at the same time? As in, did you have 2 drones out on the same night?
No. So we did, what did we do? We did 4 treatment blocks, 4 treatment transects and 4 non-treatment transects on one night. And then the next night we did the 4 other treatment and the 4 other non-treatment. And then the third night back to the first ones. And then the fourth night we did the pair of treatment and non-treatment ones. So we did it that way to try and balance the nights for the treatment and the non-treatment blocks. And in the table, I didn't actually mention, we had some lines that we couldn't do because the wind came up and it got too strong that the drone couldn't handle the wind, which is another constraint. Yep.
So do the prevailing weather conditions such as fog or cloud change the line of sight parameters?
Well, definitely they do, but they didn't in this instance. But yeah, if you can't, I mean, they do have flying at night. The good thing is because they have really good strobes on them and additional strobes, not the ones that are built into the drone. So you can see them really well at a kilometre. We did some previous work where we were doing transects for another reason, 2 kilometres away, and you can see them quite clearly. The visual line of sight has to be visual line. You're not allowed to use binoculars and that for doing visual line of sight. But yeah, the prevailing weather conditions also affect the thermal. So if you've got wind, that takes some of the temperature away, so they become less sensitive in the wind. And moisture in the air changes the sensitivity of the thermal camera. But certainly if you've got clouds and that sort of thing, you can't fly visual line of sight. Yep.
So is noise an issue for night flying with helicopters?
An issue for the wallabies or people, I'm not sure. Night flying with helicopters, I don't think you'd get CAA permission to do what we were doing with a helicopter at night, flying up a slope at 60 to 80 meters off the ground. I don't think you would get CAA approval for night flying for that. The CAA approval that ECAN's got is for hunting, but my understanding is the approval's only for flying at a at a higher altitude until they spot something, and then they sort of have a hover down to it, and then hover back up, and then carry on flying. So it's not, you can't fly close to the ground at night. I'm not aware of anyone getting that approval for a helicopter. Yep.
And possibly a follow-up question to this, would some noise actually be useful for flushing out stationary animals?
Yep. So we're about to start some work for MPI using thermal camera, high definition, so that 1920 by 1200 camera on a helicopter to do transects, but we're doing them first thing in the morning, which I think is the best time, but just after first daylight, so we can fly visually, and there's no problem with doing that with a helicopter. And I think the helicopter will move more animals, so you'll see them. They'll be a lot easier to identify on the video. Yep.
Cool. And so how much work is going on regarding animals detected and those not detected? For example, the McLean index, or every bunny you see, there's 6 that you don't, for example.
Yeah, well, that's the question about detection probability. So Dave Latham and I did some work on Bennett's a year or 2 ago, 2 or 3 years ago. And there's some more work coming up on that. As I said, it's very challenging to do because basically you have to find an area with a known number of animals and then survey it, and what proportion of that known number do you see? So if you just go into an area and fly through it and see a whole lot of animals, that's great, but you don't know how many are there, so you just can't do it like that. So it's actually quite a challenging thing to measure, detection probabilities.
And were the pre-poison wallaby counts surprisingly low to ECAN?
They haven't commented. I was a wee bit disappointed. I thought they'd be higher than that. But they were as random as we could be, and wallabies are quite patchy, just in their distribution. And as I said, it depends a lot on the weather and the wind, particularly where they are. So you can hit a really good patch, and there's wallabies running everywhere. And often you'd see a lot of wallabies as the drone's just flying to the start of the line, and then it would start the line, and you might only see 6 on the line or none. And you knew there was lots of wallabies nearby, but that's just the sort of the truth of doing monitoring. You just have to deal with that. Yeah.
So can these drones fly under a forest canopy, or if not now, maybe in the future?
No. Well, not now. I mean, there probably are little small drones that can fly in the canopy, but certainly the ones we use, the Matrice, I mean, they're big, they're, I don't know whether you can see me on here, but they're big UAVs. There's no way they could fly under the canopy. There is the SIFTI challenge, so the Strategic Investment for Technological Innovation. There's another challenge like the Bioheritage Challenge, and they have a spearhead project looking at developing new technologies for detection, which is around swarms of drones, which may fly or they might claw their way up trees, and so it's about robotics as well. So yes, in the future, whether I'll be around to see it, I don't know. But yeah, I think we'll get there eventually. And then the issue is, well, what detection system do you put on them? Is it thermal? Is it just a camera? Is it odor detectors? Is it auditory, or is it all of them? So I'm giving a talk on that at NETS, if anyone of you are going to the NETS conference coming up in August. So, yep.
Cool. So final question we have for today, Bruce. Is it possible to capture and mark animals with tags that are visible on the thermal imagery? So sort of use a mark recapture model to try and get an estimate of density?
I'm not aware of any. No, I mean, we have thought about that because it's only picking up heat, warmth, and given that's variable at as soon as you get something at a greater distance, it's it's sort of cooler because it's got more air to go through, and it can be obscured. I don't think there'd be a marker, but there could well be something out there I'm not aware of, but I'm not aware of a simple solution there. Yep.
Great. Well, thanks very much for the talk today, Bruce, and thank you for everyone who's joined us and submitted questions. Look forward to seeing you all tomorrow for our final talk around stoat and possum genetics by Dr. Andrew Veal. Mā te wā.
Thanks all. Bye.